Hi friends, I am Adarsh. I am studying Bachelor of Engineering in the branch Electronic Communication and Engineering in Sri Venkateswara College of Engineering, Bangalore. Today let's discuss about the deriving truth table from problem statement with the industry problem statement in the subject Digital System Design using Verilog in the short form DSDV. Let us come to the topic. Let us take the problem. Two motors M2 and M1 are controlled by three sensors S3, S2 and S1. One motor M2 is to run any time all three sensors are on. The other motor is to run whenever sensors S2 or S1 but not both are on and S3 is off. For all sensor combinations where M1 is on, M2 is to be off except when all three sensors are off and then both motors must remain off. Construct a truth table and write the Boolean output equation. In the DSDV and in the Boolean, off means 0, on means 1. In the question, two motors M2 and M1 are controlled by three sensors. Means M2 and M1 are the number of output variables and sensors S3, S2 and S1 are the number of inputs. Let us come to the conditions to derive the truth table. One motor M2 is to run any time. All three sensors are on. Output M2 is to run when all three sensors S1, S2 and S3 are on. The other motor is to run whenever sensor S2 or S1 but not both are on. If S2 or S1 only one is on, then the motor is run and S3 is off. Not both S1 and S2 are on. For all sensor combination where M1 is on, M2 is to be off except when all the three sensors are off. If all the three sensors are off, M1 and M2 are be off. Then both motors must be remain off. Now come to the solution. Number of inputs variable 3, S1, S2 and S3. Number of output variables 2, M1 and M2. Total number of combinations 2 power 3. Number of output power number of inputs 2 power 3 is equal to 8 combinations. Let us derive the truth table. Inputs S3, S2, S1 and outputs M1, M2. 8 combinations 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Now draw the output according to the conditions. M2 is to run anytime when all three sensors are on. When all three sensors are on means 1, 1, 1, M2 is on. The other motor is to run M1 whenever sensor S1 or S2 but not both are on. Means S1 and S2 0, 1 or 1, 0 like that. S3 is off. Means S3 is off as a 4 combination. In that we saw S1 or S2. One can on. Second and third conditions are satisfied the condition. So they are 1, 1. Remaining all are off. So we put the 0, 0, 0. Let us come to the switching equation. For M1, this is in the form of SOP. In SOP, 0 is a variable bar and 1 is a variable. Let us come to the equation. M1 equals to S3 bar, S2 bar, S1 plus S3 bar, S2, S1. This is for the output to M1 and output M2 equation S3, S2, S1. Let us come to the next problem. The conveyor system brings raw materials in from three different sources. The three sources converge into a single output conveyor. Sensors mounted adjacent to each source conveyor indicate the presence of raw material. All four conveyors have a separate motors so that they can be individually controlled. Each source conveyor can have a different speed. The output product flow rate is fixed It can be turned only on or off. The output product rate must match these source flow rates. To accomplish this, the following conditions must be met. If source 1 has a product, then source 2 and 3 must be turned off. If source 1 is empty, the source either 2 or 3 or both can be turned on. In the event no product is available from these three sources, the output conveyor must be turned off. If no product is available, the respective source conveyor must be turned off. Construct a truth table and write the Boolean output equation. Let us come to the solution. Here in the problem, we can understand that there are three sources. Means inputs are three sources, and a single output means conveyor. There are number of inputs are three: S1, S2, and S3. Number of outputs are one conveyor. Total number of combinations. So number of outputs power in number of inputs, that is equal to 8. Let us construct the truth table. Inputs S3, S2, S1, and conveyor 1. Combinations, so we know 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. Let us know the conditions to derive the output. The output product flow rate is fixed. Okay, it can be turned only on or off, means 0 or 1. The output product rate must match these sources flow rates. To accomplish this, following conditions must be met. If source 1 as a product means as a source 1 as a product means it is a 1, then source 2 and 3 must be turned off. Source 2 and 3 must be turned off means 0 0. If source 1 is empty means 0, then source either 2 or 3 or both can be turned on means 1 1. In the event no product is available from these sources, the output conveyor must be turned off. If no product is available, the respective sources conveyor must be turned off. According to the conditions, we construct the truth table for the output. Source 1 is a product, source 2 and 3 are must be turned off. It is a 1. Both source 2 and 3 can be turned on or either 1, and source 1 must be turned off. Third one is satisfy that condition, and fifth one also satisfy that condition, and seventh one also satisfy that condition. And draw the switching equation. C is equal to, as we know in SOP form, variable bar is a 0 and a variable is a 1. So CS is equal to S1, S2 bar, S3 bar plus S1 bar, S2, S3 bar plus S1 bar, S2 bar, S3 plus S1 bar, S2, S3. This is the switching equation for that output. Like this, we solve the industry problems to analyze the problem statements. Thank you, friends.